Hey everybody, welcome to our talk, A Drop of Jupyter, where we're going to show you how to use Jupyter Notebooks for a more modular and dynamic approach to penetration testing. Shout out to anybody that can get the reference. There's a hint right above the Jupyter logo. If you get it, drop something in the chat. So here's a quick overview of our team. On the next few slides, we'll be going into a bit more detail into who we are and some additional information into what we do. So who am I? I am a security consultant at Protiviti. I focus on NetPen primarily, but I also do OSINT and tooling research, and as well as operating as an amateur tool developer. So I've made some stuff that's gained some traction in the bug bounty community. I'll talk about a little bit about more later on in the presentation, but mostly, again, really happy to be here, and shout out to the guys at B-Sides for giving us this opportunity.
I'm going to introduce one of our partners in this, Cody, first. Cody is a consultant at Protiviti. He likes to refer to himself as a jack-of-all-trades pen tester. He helps us with quite a bit of everything, a little bit of web app, a little bit of NetPen, and he also specializes in mobile application testing. And he also prefers to automate report writing. Who am I? I am Nate Kirk. I am a senior security consultant at Protiviti. I specialize in network penetration testing and red teaming. I am also the infrastructure and tooling lead for the Protiviti attack and pen practice. So I actually worked with Omar on integrating this into our infrastructure and our day-to-day. And also we'll talk about that later down the road of how you can do it too. I am also a former sysadmin and blue teamer.
So just a quick refresher, if you are familiar with Jupyter or if you have no idea what it is, Jupyter is essentially, it's a nonprofit open source IPython project. IPython is a command line terminal for Python. Historically, Jupyter has been primarily used for data science, but what we're trying to do is we're trying to pivot that and show you the applications that can be used for penetration testing specifically. Quick overview again of some of the functionality and what it is. It is a platform where you can have parallel documentation and execution at the same time. It is a simple and collaborative file repository. So imagine combining like your OneNote notebook of commands, scripts, etc., while also being able to execute them at the same time. So there's no more copying, pasting, or referring back to any of your past history. You have everything in one place for your documentation and execution. And additionally, so there's also data manipulation and reporting abilities. For example, if you want to integrate matplotlib or any other libraries, or if you want to use a R kernel for your statistics or developing reporting metrics, that functionality is also there. It's also accessible via a browser, which we'll touch upon more in the coming presentation. But before that, I wanted to quickly kind of give a brief overview of why Jupyter. So the idea for creating a Jupyter notebook kind of stemmed from when I was starting out as a junior penetration tester. I found myself constantly flipping through notes, maybe like writing long bash scripts, and trying to get things to do them where I really didn't have the knowledge and the know-how. I felt like this wasn't an ideal learning environment for new testers as well that were coming in. So we came up with the idea to create a Jupyter notebook that had the commands and the documentation for newer testers, and as well as for current testers to automate and be able to standardize their methodology. And so Jupyter, in a nutshell, again, it's a simple and easy to use platform. It's a better method to facilitate the training and project execution of an assessment at the same time. It provides a collaborative environment as well as management oversight. And there's currently a large opportunity for involvement with penetration testing activities and changing things so that it's not just used as a data science framework, but more so as an offensive security framework in the future. So how does Jupyter work? Jupyter, essentially, it has an active kernel, so it enables continuous testing. That active kernel that we're using for our demonstration is written in, it's a Python kernel, but there's over 100+ kernels that you can use. So you could change your kernel to Ruby, to Go, to JavaScript. There's a lot of possibilities, again, and that kind of contributes to the extensibility of Jupyter itself. It has code and markdown that is inputted in a modular format. So for example, code is inputted into cells, markdown is inputted into cells, and those cells can be interchangeable throughout the Jupyter Notebook for more modular testing. It operates off of a server-client infrastructure that Nate will touch on later on in the presentation itself. And one of the coolest things, I think, is the combination of code that you can use. So for example, you can combine Python and Bash together to create really modular scripts, strong and powerful complex functions. And it really opens up a wider array of possibilities for penetration testing, especially when you have a Jupyter instance running on your Kali machine. So I'm going to try to go over a quick few examples of some of the highlights that I mentioned. So for example, with code in Markdown, you can see this is a very brief and stripped down, I guess, overview or demo of what a notebook could look like. So you can see at the very top, it says this notebook introduces some Python concepts. So that's an example of a Markdown cell. Beneath that, there's some Python code where you'll see print hello world and you'll see some numeric functions happening, and you'll also see the output. So Jupyter it operates within these cells. So you'll have a cell of Markdown, you'll have a cell of code, and those are typically the two main cells for functionality in a Jupyter Notebook. Here's a quick example that, again, Nate will touch on a lot more. I just wanted to show you guys kind of what the server-client infrastructure looks like. So currently, I have a Jupyter Notebook running on my Kali machine, serving it up, and I access it via a web browser using HTTPS and a port that I specified. You can also set a password, which I would strongly recommend, especially if you're working in Teams or if you have sensitive data inside of your Jupyter Notebook. So to iterate kind of what I was talking about, the Python or any other code really combination method. So this is a quick example of how Python and Bash can be interactive together inside of a Jupyter Notebook. So you'll see that there is a mix of both Python and Bash scripting. As you can see, I've created a list variable in Python, and inside of that list are contained 6 strings. So in the next 2 lines of codes, I've used a loop to iterate across that list. And instead of using a Python print statement, I'm passing the variable I, set in Python to Bash, and using that Bash command to perform an echo to output to the Jupyter Notebook. So this is a very simplified version of what you can do, but I hope that it illustrates at least the possibilities that are available while using a Jupyter Notebook for penetration testing. So some key issues that we've noticed and kind of the reasons behind why we wanted to create a Jupyter Notebook for penetration testing or performing penetration testing related activities. There's that current frameworks such as pen tester framework or any other methodology that you might be using. Maybe you have everything just dropped into a simple bash script. But other frameworks lack the extensibility, the modular nature, the documentation, the markdown, and the collaborative nature that Jupyter Notebook has to provide additional functionality within teams. So what Jupyter is better at than other frameworks, it has a specific set of documentation, magic commands, notebook extensions, and it's very easy to use. There's a GUI. It's not something that's necessarily complex or difficult to start off with for newer penetration testers or penetration testers with more skin in the game. And like I mentioned before, it's collaborative in nature. Due to the nature of the file explorer, anybody can download a file, upload a file, edit a file, as well as the Jupyter Notebook itself. And some of the issues stemming from that are the current environment of how some of our penetration testing activities are conducted. We see that there is a constantly changing landscape of new tools and methodologies. So this makes it difficult to constantly update frameworks. It makes it difficult to share these framework updates or tools or anything new that's popping up in the community. And as a result, we kind of see that there's a lack of a truly collaborative and modular framework for pen testing itself. So combined with a lack of standardized methodology within teams, there's also a resultant factor of documentation sprawl within teams, especially for newer pen testers, so it makes it really hard to kind of hop into the game. A sprawl of commands, scripts, notes that are usually kind of just littered everywhere. So having a centralized repository really helps with that. And it will start to reduce another issue, which is kind of the barriers to entry for newer testers. So our solution is relatively simple. I hope that y'all have guessed it by now, but we want to utilize Jupyter Notebooks to develop modular and standardized automation frameworks for the execution and documentation of core penetration testing activities. And what we'll do to kind of illustrate that is that we'll go over into a demo of some OSINT, of an OSINT notebook that we've created. And it's a bit of a stripped down version of what we use in the lab itself, but nonetheless, it's a good explanation of the functionality that that you can leverage with Jupyter to perform key activities. Excuse me. So here's a quick overview of what we're going to be covering and the functionality that the Jupyter Notebook will conduct. So on one side, there will be subdomain enumeration, then email enumeration, and vendor service enumeration. So there will also be some additional functionalities happening in the Jupyter Notebook that we will work through live. So after some of the data is gathered, there will be some formatting, verification if a domain's alive or not, and then ultimately at the end, parsing a deliverable that management can look at due to the collaborative nature of Jupyter, or for anybody to pull down. And so we'll go ahead and start the demo. Okay. And so just to give a quick overview as to kind of how Jupyter is structured and maybe make some of the stuff that I was talking about sound more practical. So Jupyter, like I mentioned, it has a file repository. Within this file repository, I've created a folder called demo. Within this file repository, you can see and view all the running Jupyter Notebooks. So you can see I have some of my personal ones that I use for testing or for bug bounty or things of that nature. And there's also, like I mentioned, extensions that you can use to change how your code is displayed, reporting features. There's a lot more than what's being displayed right now. There's a lot of functionality that you can add with these extensions, but for now we'll try to keep it as basic as possible. So moving on into the Jupyter Notebook itself, I'm going to go ahead and kind of just walk through some of the additional functionality that I showed. So Jupyter has a file tab. You can open, you can check the version history if you're using it for collaborative reasons of how the Jupyter Notebooks change, similar to a Google Drive or something of that nature. You can download the notebook, and there's additional functionality within the cell running functions. So you have, again, like I mentioned, you have code cells, like how you can see in the start time that I'm putting. And you'll see that I've imported the date time, and I've printed out the date time as a start time. And again, some of the data right here is not accurate, but I'll clear it, and then hopefully they'll give you all a better idea of how the Jupyter Notebook runs. So I'm going to go ahead and clear all the output. And now you'll see no outputs coming from these tools. But as you can see, I have some markdown, and then I have some code cells. So in one of the cells, there is a setup script, or a few cells of setup that are run during the Jupyter OSINT notebook. So for example, in this cell right here, I'm setting all my variables to be passed throughout the notebook. So in Python, I'm saying that the domain is protivity.com. I'm saying that the client is Protivity, and I'm creating a folder name called demo to store all the outputs from the notebook. And here again is kind of an example of a combination of Bash and Python scripting, kind of like I mentioned before, where I'm performing a host lookup on the Python variable, except I'm doing it in Bash, and then I'm storing the output from that Bash, or grepping that IP address, and storing it back into a Python variable. So I hope that kind of illustrates the dynamic nature of code within Jupyter. So I'm going to go ahead and run this cell block. And it's relatively easy. And I've already created the folder, so you'll see an output that says the folder cannot be created, which is totally fine. And then I'm going to print out all the variables that I just set, so I can show you all kind of how it works. And now you can see that the client name has been set to Protivity, and so on and so forth. Another core portion of the setup script is the tool initialization script, which we don't have to go into too much detail. Again, it's relatively straightforward. Essentially, all it's doing is it's trying to create a modular framework for me to reference tools in the notebook. So for example, instead of specifying the whole path of a common tool used in OSINT, like subfinder or sublister, it will just perform a locate and then store that path into a dictionary so I can reference it throughout the notebook. And so I'm going to go ahead and run this script to initialize all the tools that I'm going to use in the notebook. And you should start to see some output. So you'll see that all these paths have now been set into a dictionary. Now going back to kind of the overview that I showed, one of the first things I wanted to show is our subdomain enumeration process. Again, this is a bit stripped down because of time constraints and the nature of the demo. So I kind of wanted to show you guys how a standard tool like subfinder would look like being run inside of a Jupyter Notebook. So all I have to do is the command is already written in there. If I'm a new tester and I've never run subfinder before, I can read the markdown description of what it does. And all I have to do is click run inside of the cell block, and it'll start to enumerate the subdomains for me inside of the notebook itself. So it mitigates the need to really understand, I guess, terminal commands in general. Of course, that's something that's important, but for training and automation purposes, this can be something that's really useful during assessments. So subfinder will run. Once subfinder is completed, then the next tool will run. The next tool is called Asset Finder. It's written by Tom Nam Nam. And similar to subfinder, it performs the same functionality, but typically when doing OSINT, you want to kind of spread your landscape a bit to see and use multiple tools to get as many subdomains as you can. So I'm going to go ahead and run the Asset Finder. And now that's going to run, and similarly to subfinder, you'll see that the output is coming out in real time towards your notebook. Now, one thing I do want to show is that I'm performing a T in bash to store all these domains into the notebook itself as a separate file. So I can go to my folder, or anybody from my team can go to my folder, and they can go into B-sides demo for all these purposes. And some of these are already run, but they'll reiterate and overwrite as we go through the demo. But this domains.csv, you can see it was just modified seconds ago. It's the one that we just ran. So I can go into it, and I can see all the subdomains from Asset Finder and Subfinder outputted together. I can edit this, I can send it off to somebody, anybody can pull it down. So this really shows the collaborative nature of Jupyter itself. But of course, a common problem is that you have all these subdomains, right? But I would need to dedupe them. So within Jupyter itself, I have a small script to format and dedupe those subdomains. So we'll just take a look at this again. I have about 870 subdomains, not unique, but I want to sort them and get all the uniques from them. So in Jupyter, I can run the bash script that I wrote, or anybody can run it, regardless if they have batch testing experience. And it'll give me an output that I wrote in Python to let me know it's complete with the print complete statement. And I'll go ahead and go back to domains, refresh, and I'll see now that I'm left with 344 unique subdomains, right? So again, I hope this illustrates the ease of use with this. You're not typing commands, you're not copying, pasting from another notebook or from your notes. You have everything in a centralized repository for testing. And everybody can use the same standardized methodology for testing that you are. And I'll go ahead and give a quick overview of some of the additional functionality inside of the notebook. And then I'll go ahead and do a run all, so you guys can kind of see how long it takes for the automation to run, for all these commands to run and things like that. But in a nutshell, kind of like I showed in the overview before, I'll be performing some additional commands like verifying what domains are live with this bulk reverse DNS script. I'll be scraping emails via the Infoga tool. I'll be looking at Shodan, which is going to take all the IP addresses from the subdomains automatically and then put it into Shodan for running and searching on various queries. I'll also be looking at cloud enumeration to see what cloud assets are available. We'll also be pulling from a breach list to seeing what information is on the breach list for the domain that we're using, which is protivity.com. Of course, that information will be redacted and deliverable, so there will be no passwords or anything of that nature. And then a personal script that I've developed called getDorker, which essentially what it does is it automates the dorking of GitHub dorks on a specific domain. So for example, if you put in protivity.com, it would run a query on password, connection string, et cetera, and of course, all that information is already redacted, and more so, the only results that you'll see are from my own GitHub repository that I use to kind of show fake results. So, and then towards the end, there is a parsing script that I wrote that will parse all the outputs from this notebook into a clean and nice Excel deliverable. So you can use that as a base point. You know, I'm not saying that this is like a perfect method for OSINT, but you can develop a very strong base to work off of, regardless of your experience, by using Jupyter Notebooks and by collaborating with people and creating stronger Jupyter Notebooks due to the modular nature. It's a very easy base to build off of and improve on in the future. So I'll go ahead and run the Jupyter Notebook in full. And the way I do that is I will start at the top and I'll click Cell and Run All. So now the Jupyter Notebook will start to go through each of these cells. So you'll see the start time printed, and this is just something I wanted to put in just to show you guys how quickly the Jupyter Notebook can run. So it started in military time 15:45, in our time 3:45 and 37 seconds. You can see that it's run through the setup script, so it set the domain variables, and it's run again through the tool initialization script. And I'll go ahead and minimize this. And it's currently running through SubFinder, and it's going to run through Asset Finder and go subsequently throughout these different scripts that were personally wrote and also brought in from third-party resources or tools that were developed online. So again, there's a lot of functionality within Jupyter to put in your own customized scripts with Python and Bash scripting to create a really truly modular framework for pen testing itself. And so as we go through, we can see that now the email gathering portion has started. And then after that, Shodan will start taking all the IPs that were automatically grabbed from the DNS probe, and then so on and so forth through until all the tools are completed. So while we let this run, we can go back to this, but I want to kind of show you guys a quick heads up into what the deliverable itself will look like. So if you can see here on my screen, I have an Excel deliverable that would be parsed at the end of this notebook. So what I have is I have all my alive subdomains, unique and sorted, A through Z, and the corresponding IP, which makes it a lot easier for a tester to just view and be like, okay, I know what's live, I know what to test. I can create a new column for comments, check what's there, check what's not there, and standardizing that methodology so we're not running into inconsistencies while we're testing within teams. And again, here you can see the cloud assets that printed or that outputted from the cloud enumeration tool that was used. You can see a tab for IPs only if you want to do some further testing on IPs themselves. You can see the Shodan output of all the IPs that were queried against, and you can see the various ports, of course the results of those ports, and so on and so forth. And then you can also see the tool that I developed, getDorker, where it will output the dorks themselves, the specific URL to hit to access the dork, so you don't have to put anything yourself, and the number of results for you to filter and search through. And then here's the breach list from the command that we ran to pull in breach list data from dhashed. As you can see, everything's redacted for obvious reasons, so there will be no stealing of passwords here. But I did want to show you guys the functionality and the ability to pull things, large data sets, relatively easily with Jupyter. And then finally, as you guys saw before I switched over, there was a script running called Infoga to pull email data. And so this is already cleanly parsed and scraped from Infoga and outputted into one clear deliverable. So again, there's no additional actions that I'm taking at the end of this notebook. All I'm doing is I'm clicking cell, run all, and then I'll have this whole entire Excel sheet parsed in a clean and nice format for me to continue on as a base for my testing. And so let's go ahead and go back to see the OSINT itself. So you can see that it's currently running the showed-in script. We can check back on this later to see kind of like the time and how long it took for it to take. Typically showed-in will be the longest portion, but as you can see, the rest of the tools they ran in within seconds. But because of the large number of IPs for the domain, showed-in might take a little bit more time. So what I'll do now is I'll go ahead and hand it off to Nate for the infrastructure piece.
Okay. So as Omar was going through the demonstration there, I'm sure a lot of people were thinking, what does the underlying infrastructure look like for something like this? I was thinking the same thing as we're actually going through this and creating and experimenting with things is, what kind of horsepower do we need under the hood? What is this going to look like when we roll it out to an entire lab? So luckily, Jupyter is actually pretty lightweight, and a lot of the tools that we're using are also very lightweight. So we actually deployed this at first just on a T2 micro, moving up to a T2 medium in AWS at first. So it's really accessible to anybody. And even in the demonstration that Omar did, it was actually running on a local Kali instance. So we prefer to use the cloud due to some of the collaboration ability with it. But this is something that anyone could run pretty much anywhere on any flavor of OS that they want, with some, as long as you're hitting those requirements for Jupyter itself. So talking about AWS, we really enjoy it because of the, being able to stick something, and really not just AWS, but any cloud provider, being able to stick it on a public address and then actually, restricting the security group and network ACL down to just letting certain people or certain lab IP addresses or VPN addresses to get to Jupyter itself, or really just to get to anything of ours. So by restricting that, but still opening it up to everyone, I'm able to jump on from my VPN network, my Protiviti VPN network. Omar's able to jump on from his in a different lab. So I'm able to jump on, do something. Omar's able to jump on and actually pull down that deliverable or go check how OSINT's going on one project. It's made it really collaborative from that point. So for us, we prefer to have a new instance each time for each new engagement, so there's no kind of data contamination, crossover. If a tool breaks, we're not worrying about it. And it also kind of opens up experimentation for people of, hey, if you want to add a new module to Jupyter, feel free to go ahead. If you break it, we'll just spin you up a new instance. And we're actually doing that through just bash scripting. That's how we actually deploy Jupyter to Kali instances, is just a bash script that goes and pulls it down, pulls our configuration file, which Omar was talking about. You can customize SSL, put a password on it, change the default port, do all kinds of cool stuff with it. So really, it's accessible to anyone that wants to do automatic installs if you want to. It's fairly simple. We're actually running it in a screen. We've had a lot of good experimentation with that and have seen it proving out. Also, since our instances are disposable, we haven't had too many latency issues or issues with that. One of the great things about Jupyter is the extensibility with it and some of the kind of crazy use cases you can use it for. And also, the thing that I really love about it is with the markdown, you can actually be teaching people as they go. If it's their first time running something or the first time they're ingesting data into it, it is really impressive. There's so many different forms and tasks that you can actually integrate in with Jupyter itself. Just an example is Bloodhound. So you have all that data, but you want to actually do some cool custom queries, and you're doing it at the same time on each engagement, but you want to automate it engagement to engagement and make sure it's consistent throughout. Instead of actually querying Neo4j or the backend database yourself, you could actually just add that as a module into Jupyter and have it do it for you, and have an explanation before it, and then have it run, and then have it deliver a nice deliverable output that can help you with your hunting. Other things like that with offline data would be doing Active Directory reviews, doing Azure or other cloud provider reviews, or even O365 reviews, where you're pulling in large amounts of data, even raw data, into a database. And as long as you have an ability to actually query it, either through bash, like the command line itself, or through an interface of a database, you can actually automate that through Jupyter and still make it one at a time explanation and make it pretty simple and concise. Also, the reporting, as Omar showed with that Excel sheet output, really helps with kind of digesting and even making a formal deliverable for a client, or even for yourself if you're trying to stay organized, doing bug bounty hunting and trying to keep everything sorted out. I know mine's sometimes a mess in notes. This has really helped keep it condensed and keep everything in one central spot. So really, just to sum things up, if you can script it in any programming language, and you can do it in like a formatted in Markdown, Jupyter can handle it. And the beauty of that, the modularity with it, and also keeping it in a simplified format, combined with its functionality of connecting it to like a Kali instance and having your custom tools on it, or just pulling in new cool tools from GitHub, the possibilities are really endless on this.
Awesome, thank you, Nate. So before we go into some code release stuff, I think what we could do is we could go and check back on the Jupyter Notebook, see how the runtime is. I'm positive it finished probably along the same time when Nate was talking, but we didn't want to, put a stall in the presentation. So just give me 1 second. So picking back up from where we left off, we were leaving off at Shodan. So we can see that Shodan, or a script for Shodan and scraping, is running to query all these IPs that we got from our reverse DNS. And it's already finished. It gives us some output saying that it's stored as Shodan. That's the name of the output file. Some vendor service enumeration was conducted using a tool called CloudEnum. And it's given us these buckets that we saw previously in the Excel deliverable. And then a pull for the dehash breach list, which we also saw from the redacted information. And then again, my personal tool, GitDorker, it runs automatically inside. And you can see all the terminal output as well, showing you various links you can click on, or for probably an easier experience, you can go into Excel, format everything, how you want to do it, sort it, and so on and so forth. And again, you'll get output telling you where it's been stored. So I can go into the B-Sides demo folder, and I can see all the information that's been stored individually. So if I want to go into emails, I can see emails. I have full right to edit this. If I want to add something, I can add my email in here. Right? So it's relatively simple. I can save it. So if I click out of this and go back in here, you'll now see my email. And so on and so forth for the rest of the outputs. The beauty at the end, like Nate iterated, was that there's also a parsing script that runs at the end that parses all the CSVs that were outputted into one Excel deliverable, which we demonstrated before. So it's relatively straightforward. Again, you can modify this as you'd see fit, but we'll touch on code release once that comes out. And towards the end, we'll see that the Jupyter Notebook itself had an end time of 1556 or 356 our time. So we started at 345. So you had this whole Excel deliverable parsed and ready for you within 12 minutes, right? Which I think it's a great base. It's a great start, especially for somebody who has no idea what pen testing is or bug bounty hunting or wants to get a start to their OSINT. This is a perfect way for them to get started, remove those barriers to entry, and have a good base to start off with in a relatively short amount of time. Remove all the wasted hours from training, and also expedite assessment time during penetration tests, especially for the corporate environment. So now we'll go ahead and go back to the presentation itself. Can y'all see it? So talking about code release, so the release context, the Jupyter OSINT notebook is formatted like the rest of Jupyter Notebooks in the .ipynb format. So it is run within the Jupyter platform. Release date, we're planning to release within 1 week of the time that this presentation comes out. The release locations will be in my personal GitHub, so you can find that at github.com/obeta12 as well, and I'll have some information coming out regarding blog posts and how to really perform Jupyter modifications or creating your own Jupyter notebooks through my Twitter, which you can see it. It's the same handle, obeta12. And then lastly, just some follow/contact us. So I already mentioned mine, but Nate, you can follow Nate at Naterang at Twitter. But aside from that concludes our presentation. Again, super happy to be here. Really thankful to all the guys at B-Sides that made this possible, especially with the hassle with everybody being remote and the craziness that is COVID. So shout out to those guys. And now we'll be taking any questions if anybody has some.